Okay, everybody. I think we're going to try to bring these last 2 days to hopefully a successful conclusion. For me, anyway, it's been an interesting 2 days debate. One of the things that we do within the DRL, which I think is really important, is really try to open up not only the discourse, the methodologies, and the things that we are trying to achieve within our agendas with what we call design research, with issues to do with experimentation, and open that into a format that is open, participatory, and accessible for people. I think as we're sort of bringing to close something that we're calling proto-design, I'd just say a couple of words about the last couple of days before I introduce Tom Wiscombe. We set up a kind of problem which is speculative, and in doing so I think it's kind of really important to qualify a little bit the necessity today more than ever to actually really embrace a kind of attitude that design actually has value, meaning, and is purposeful, but that also is not habitual in the sense of leaning too much on the way that we do things as an evaluation. We live in a very radical time, I would situate. And I would say with that, it doesn't mean a radicality which I think has been part of the so-called avant-garde discourse, but much more being humble with the complexities of what architecture is, has always been, and will continue to be. In a moment when architecture actually is trying, in many capacities, to assert its value in everyday society, I think you, as being a younger generation, have the obligation to yourselves, starting with that, but much more to the people that you're creating architecture for, to communicate what it is that we actually do. It's a moment when a lot of people are saying a lot of things, but really what they're talking about is something that is abstract and that's sometimes not legible. Though the demands of the built environment, the crisis of all kinds of issues are sort of put out there, it's also put out there as a kind of idea, as a rethinking what we've been doing for the last 20 years and sort of putting our tail between our legs, so to speak, and talk about architecture as if technologies, discourse, design could not be experimented, pushed. Innovation could not reside within architecture with all the technologies that we're talking about. And at the moment when we actually have a community, I think, of very like-minded people with their notions of open source, with the attitude and accessibility that this knowledge is, it's more imperative than ever that people actually really do look at design research, value it because it's not necessarily so much a part of practice, though that we would really like it to be, and consider your obligation and accountability within that. We try to make things accessible and available. We try to foster an idea of community, which is not a 60s kind of concept of hippiness, but we try to interrogate different projects. What I think is important is also to celebrate diversity, and as I think you can see, between faculty, between invited critics, also have the respect for the projects that are there to value the difference and understand that there isn't a way, but multiple ways. They still demand rigor, they still demand passion, sensitivity, and all of these other aspects. But for no way, shape, or form is there a guiding outline that sort of is a blueprint for how you're going to operate. Thinking about proto-design for me has actually been a very important feature. Having those kind of everyday battles with my colleagues every 2 weeks, with students who sort of embrace the ethos and try to push this project forward, I think has shaped a kind of discourse and enthusiasm which I value greatly, is one of the reasons why I maintain myself in this context, and why it's also really difficult in certain times to sort of stick within a kind of conversation that doesn't necessarily evolve. And part of the evolution is also understanding that this doesn't begin and end with the students, with a project that's presented here. The value of a lot of these things is actually, I hope anyway, that our students have a conviction, and you do as guests to this place, that these things can be implemented, should be implemented, and that you have the courage to believe that those things actually matter. With that being said, I think it's a very purposeful part on my part and the faculty to bring Tom, Peter, David, a whole host of collaborators like Marta, Alyssa, Philippe, to really engage in those conversations with us. This happens at the end of what we call phase 1, and it happens as well in an environment like this is what we call a phase 2 thesis. Tom, I think, is a really important figure as far as I'm concerned within contemporary architecture because he is a very passionate guy. He's going to tell you otherwise. But at the same time, he's a true believer in architecture. He's done his time in offices. He's tried to understand the complexities of building. I have a very deep respect in what he does and continues to do, no matter what it is. He forces this sort of action, if you so to speak, in his own practice to develop new work. And I think today, more than ever, when people reside in a comfort within academia, not only is it refreshing, it's imperative for you guys to understand that practice is the objective. Building, whatever that means for each of you, is not an option. It's a necessity if you're going to actually think about the value of what we do. If you read in any form of contemporary discourse or evaluation of the status of architecture, architectural education, you will recognize that people really don't have much belief in what we do. I think I am more encouraged more than ever when you see a room here that is actually completely packed with visitors, students, coming to see, hear, talk with other students. They're not here really for me, for Patrick, for Peter, or for Tom. I mean, this obviously is for Tom. But I think it's really important over the 2 days to understand the power of what it means to actually be a student as an active participant in all of this. I put this out there as a little bit of a calling because I think it's part of my obligation in this context, and to understand that this context is not something that's particular, it's just something that's mandated by the people who operate here. So between SCIARC, between other schools, there is an affinity towards design. I think Tom embraces that active engagement both within SCIARC and with his own practice. He's going to share his work with us. He develops a kind of attitude towards the prototypical, which I think is really engaging. But he also does that in a way which I think is quite unique to a lot of contemporaries, which is he tries to look at the mechanical systems, the everyday subsystems, tries to fold that in within the discourse of making. But that discourse of making is not a fallacy of representation. That discourse is actually embedded with a knowledge of what it means to make a building. I'm really hopeful that he gets that opportunity sooner than later, because I think it's going to be worthwhile attribute. So with that, I'd like you to warmly welcome Tom Wiscombe to the AA.
Theo, that was great, and I really appreciate that. I do, and I wanna say how great the work was today and yesterday. It's a treat to come and not just feel like, you know, as a juror that you're giving back on a favor that someone's done you, or that you need to do your time on a jury, but that you come and you learn. And I have learned so much in the last 2 days. It's really fabulous work. It's also significantly different than the work going on at SCIARC, and so it's very interesting for me, I'm sure for Peter, to come here and see in a way the AA is a sister school to to SCIARC, but in a way it's not. And those differences are things that we'll continue to talk about on the airplane back. But it's really productive, and it's nice that we're separate, and it's nice to come together and then share what's going on. I have to say, in particular, the work that you guys have done with materials and with new ways of deployment are cutting edge, amazing. I'm really impressed. I don't know if I have much to add to it. I'll throw out a few prototypes that I worked on, but I did want to focus more on building objects today, because I knew that we would mostly be looking at prototypes. And some of the complexities and toughness that goes into making a building, which goes beyond maybe material and engineering considerations, which are possibly disciplinary and other and even social issues. So I want to break this up into 3 chunks, and we'll go about an hour. And Theo, you're going to tell me 10 minutes, and thank you, because I don't want to keep everybody. Composite tectonics, squishing and embedding is the first chapter. Surface to volume and objects inside of objects is the second one, and tattoos and the status of subdivisions is chapter 3. At the end of that, I'll show some projects in China which fit some of those and are the closest to realizations that I've had to date. So, as we've been discussing today and yesterday, I think there's a lot of interest in composites. I'd like to point out that the first, or not the first, but that the most recent composite construction in 20th century architecture, of course, is the composite deck, which you'll find in almost every building that involves steel or even concrete frame. And the mineral materiality is what I like to call it, the mineral paradigm, and all the things that entails, including vector structures, infill panels, and all sorts of trabeated hierarchies that you get in construction. And I like to think of new ways of dealing with that. And I need a lexicon for that, I realized. And I started listing words recently, and it's driving a lot of the work that we're doing in seminars and in studio. And one of my favorite ones is squishing. Squishing is not a word you can use with steel and concrete. You can squish polymers, you can squish biomaterials and composites. So sucking, melting, grating, healing, and bedding, inlaying. As we know, looking at things in nature, the fly wing, amazing. How can structure be transparent? Of course, the fly wing is made out of any number of materials, resilin and chitin and elastomeric and all kinds of biocomposites that are actually 10 times stronger because of the helicoidal strands that are in them than the composites that we're currently using in aerospace and aeronautics. I don't say architecture, by the way, because they're hardly ever used currently, and a lot of the composite construction that we're talking about today is, as I mentioned in the last review, is not state-of-the-art yet, but it's in the pipeline, and it will be, I think, in the next few years, at least in terms of building cladding and other issues. The crab shell, amazing. What I love about the crab, pleated, colorful, lots of new, potentially architectural features in what's otherwise a very thin shell construction. And also, as we finished up the final review, we started talking about multi-materiality. That's a fact, and it's quite exciting to think about the idea of eliminating the concept of assembly altogether, where suddenly things are made with their component parts in a single pass, or maybe two passes, but very exciting stuff that's going on with multi-materiality right now. Not only just different materials, but gradients of rigidity and stiffness and transparency and opacity of materials, which I think is, for us as architects, almost more important than the performance and engineering issues. So with composites, one of the most important things for me is that you don't have conventional subdivisions, or you don't need to have them. You can choose to have them, but you don't get any articulation for free. In the 1950s definition of tectonics from Kenneth Frampton, where you have to deal with material limitations, be it bricks, masonry, metal panel. You don't have to deal with the fact that stainless or aluminum comes on a roll, usually from Finland, which is either 1 meter or 1.50 meters wide. And so you've automatically got a seam at those locations, no matter what you do with the length. So I think that it's important as architects, because I think this is one of our roles, it's important for us to figure out what is the new tectonics. And it's definitely not the tectonics of the surfboard, which is just a piece of foam with composite pressed all over it, which is very homogenizing. But it's incredibly freeing also to work with composites, because we have a whole new way, and we saw today in some of the projects, a way of dealing with joints, a way of dealing with enclosure versus structure, which can be more continuous than with trabeated steel structures, multi-material embeds, super components. Actually, we saw this afternoon in one of Rob's projects, which I thought was great. The meta seams are my word for any kind of seam which doesn't need to be where it is, but is there at the choice of the architect, and maybe a joint, maybe a seam, maybe a structural reinforcement, but we don't know, and it's up to each architect to kind of decide with composites. So, as a model, the Korean seafood pancake. I live in Korea, a town, Koreatown, in LA, and we've been working on some prototypes involving crossovers between Maya, ZBrush, and actually now the robots at SciArc, which is pretty exciting. I'm calling the robots now our post-human tattoo artists, actually. And I like these models very much because they seem to compress or fuse things together into new kinds of things which are definitely not assemblies, but definitely have different qualities and material properties pressed into surface or pressed into objects. So this is a project from one of my students a few years ago. We were dealing with multi-materiality and in a very low-tech way, and it's pretty exciting when you can begin to inlay things of different rigidities and see how the performance changes from something that's very, very weak silicone to something which is more rigid like cartilage to something which is hard like a 3D print on the far right. In particular, on the far right, the fact that it infers a discontinuous skeleton, that you could begin to take surfaces and embed skeletal or extremely rigid members into them without them making a frame. So a kind of discontinuous skeleton. This is another project from a seminar last semester at Yale. One of my students in my Squished Assemblies seminar, where we began to figure out what would it be like when we start to press and embed objects into surfaces in place of fixtures. I'm really interested in eliminating all kinds of metallic hardware also. In fact, I have a kind of allergy against things that are mineral and fixtures these days, so I'm trying to figure out how we can deal with composite construction, but also with all the other things that architects need to deal with, like lighting, and in this case, this is a proposal for thin film solar, or other kinds of systems that might start to get embedded in this case, in an inlay, and then fused on top with a piece of acrylic that has its own kind of metaseam around it. So this is Batwing, a project from, at this point, many years ago, but I want to show a couple of these prototypes because I know you guys are working on this, and I'm not sure if you're familiar with them, but this is from 5 years ago, and it was a first attempt to deal with surfaces beginning to delaminate. And in this case, what happens when a surface can be not just a single surface, number one. Number two, what happens when it begins to delaminate? You can start to get some structural rigidity, and also you get cavities. The surface starts to become volume, and you can use that volume in order to move air and fluids and things like that through an assembly. So this is a kind of a prototype for a ceiling where you can get rid of the air diffuser, and you can basically, on the double delam, and you can basically replace fan coil unit technology with a surface that does some work. So you basically have some squished microcapillaries which are heating and cooling, so all you have to do is deliver air, and then these are filled with water, which is a great way to deliver heat and cool to rooms, and then you can run the air across it. So this is one of the earliest Squish projects, and here's a prototype of that. You'll notice also, if I had my pointer, you'll notice some metaseams beginning to get formulated there, some seams on the prototype which don't actually have anything to do with components in that case, which are there purely at the architect's discretion. Another one, again, that these are 4 years old now, but I thought it would be fun to show them. This is gray water panel, also known as lizard panel, and the idea was that it's an algae bioreactor. So you have to imagine that these diamond-shaped profiles are actually in a transparent form, and you're running an algae system through there, which can create lipids or biofuel at the back end if you put algae in there with carbon dioxide. And at the same time, that creates channels and sort of canyons that will collect gray water and then cycle that through down into the building. One thing about that is that I'm not giving up on the idea that the structure can be maybe sideways to that, and that maybe the top cord is running the algae back to a central, and the bottom cord is running the water, but that the structure may very well need to have a different kind of direction or language than the systems at the top. Another one, which I'm really interested in this one, actually, having kind of dug it up. This is called thermostrut, which is trying to deal with aperture, pleating, and most importantly, the embedment of a solar thermal system, like you would find in a swimming pool on the roof of a house, warming the water for a swimming pool. So you tend to find those black coils. So this is our version of that, where you can begin to create figuration with these coils. I would call this the earliest tattoo project from the office, where there's no actual functional reason why the coils have to be all parallel, and so it can begin to become figural. And at the end of the day, I almost care more about the outcome of the wholeness of this piece through color, through the black line work, through the pleating, the kind of unification of all of these things. I care more about the effects of that than I do its sort of engineering efficiency. So there's a model of it, things actually being pressed in. This is a multi-material print from a couple of years ago. Another old project that I showed for the concept of metaseams, you'll notice here that these panels are way too big. This is not a metal structure, and when this was done in 2008, there was not as much discussion about composites, and I was even unsure myself. It was a kind of intuitive move to begin to break down these panels, create toroidal structural surfaces in the middle of this thing, but also begin to break down the panels in a really radically different way, where you have very, very small panels and very, very large panels. And of course, when we imagine this through composite construction, we can imagine that those may or may not be joints, depending on how the project is delivered. So there's that project. I want to show you a project I did with my students, because I had some discussions with Patrick about it recently, and we were working on, actually the program is called Materials Lab. We started it a few years ago at SciArc, and it basically involves the school supporting the construction of an object in the school using advanced materials, or whatever materials someone wants to use. In this case, we kicked it off with the idea of heterogeneous composite construction, which basically means, again, the surfboard idea. How is it that composites can begin to not only just be a kind of a single layer over a piece of foam, which is just doing its business in terms of performance and stiffening, and also how can you begin to have gradient differences in thickness and change the performance of composites as well. So we decided to do this with tape, dyed orange tape. It was the only reason it was orange is it's the only dye that would take to the glass fiber. I don't know why the glass took the orange dye. It's shoe dye. We wanted to do black. But I like it because it looks extremely low-tech, and there's something charming about composite construction that is the opposite of high-tech. I like the low-tech, almost like it was dug up out of some kind of archaeological site, with all the amber colors and the kind of fluidity of it. I like that very much. So that was a quick study of it, a prototype. We worked with Barreau-Happold on this, doing surface structural analysis, which is still new to a lot of architectural engineers, as people in practice know. We talk about surface structural analysis a lot in academia, but the reality is that it's the aerospace and naval engineers that are really good at surface analysis, and the architectural engineers are still stuck with vectors, usually. So this was fun for Happold, too, to get up to speed in ANSYS and begin to analyze the structure for cantilever. So we did a series of steps. This is actually, I didn't want to show them all tonight, but we did a series of steps to get to this point even where we could add the tape. The pleating was something that evolved over time, but this is, we decided to use the tape in order to deal with some of the stress high points. And so this is actually from an email that I sent over to Happold when we were starting to talk about how to apply the tape, that I wanted it to be kind of patchy and discontinuous and not wrap the entire thing. So this is the piece. Wherever you see orange, imagine that there is at least 2 layers of weave on the piece, up to 4 or 5. So the overall thickness of the piece is very, very thin. It's like a 1/16 of an inch, and it's just fiberglass matte. It's completely underdimensioned. So if you were to put this thing up without the orange tape, it would fail, which is exactly the concept, so that we need to add the tape locally wherever it's needed and start to build it up, particularly at the supports, so that it functions. Now, I want to say, this is probably not the most optimal solution, and that's again something that I'm a bit against, which is the expression of optimum and optimal engineering solutions. So any trained eye will look at this and see where it's not optimal and where there are other things going on here. And at that moment is when I started calling it structural tattoos. Because what is a structural tattoo? It's an inexact term, and I like it very much. There are obviously things that are not structural, and I'm totally good with that. There it is when you turn off the rest of the skin, the taping. I guess I missed some slides. What happened? Oh, that's out of place. All right, whatever. So one of the things about composites that we saw today also is how do you break it up? It's completely different. Depends on whether you are building it in situ. In this case, we built it in chunks. And how do you attach chunks together? We wanted to, actually in an almost maniacal way, I wanted to have no hardware in this piece, only glue, which created a lot of problems. So we had to do the components. Why? Because we had to get them through the doors of the school. It had nothing to do with delivery, but we had to get them through the doors of the school because we were working with a contractor outside of the school. So we built these things in pieces which already had the orange tape on them, which is interesting because there's not really much continuity then between the pieces, which doesn't really matter in terms of composites, which is very interesting as well. This isn't like a piece of rebar that has to have rebar sticking out at the end and then be continued into the next piece of concrete. I thought that was very interesting. I also like very much that we're looking again at structure, which is translucent or transparent, which changes. It's a game changer. So here's us making some of the forms, and there's some removing some of the molding, and then very low tech again with projections, figuring out where we're going to put the tape on this thing in the factory using the 3D print that we had and our black duct tape. And then here's the piece standing in the space. It's connected back to the wall at a couple of points, and it cantilevers quite far out. There's the final thing, and that's Andreas Frosch from Machinist, who helped us build this project. And it's quite resilient. It bobs up and down, but it doesn't really go anywhere. And another thing that I like about it too that I didn't realize is we discovered after talking about it that if it fails, it doesn't crack or break, but it will fold like textile, like a stiffened jacket. So even if it fails, it's not going to really kill anybody. You'll see it coming. It'll fold down. But anyway, we got a bunch of people up there. So that's that project. This is more of a thought project, and it's not very well developed, but I show it in relation to this idea of multi-materiality. Car design has been really, it's a very interesting history, actually. I'd love to do a longer in-depth study on it, but you basically have 3 types of structures. You've got the ladder frame at the top, which you'll find in trucks and large, kind of large vehicles, buses, where you basically lay down the frame with the wheels on it and everything sits on top. You've got the space frame, which you found in race cars from 80 years ago, but also contemporary high-end sports cars like Lamborghinis. And then you have the unibody, which everybody knows because it's basically most cars are made unibody style. Monocoque construction, very, very thin metal. Stiffness is generated by folding or pressing into it. So alternative. We thought a lot about cartilage and the idea of semi-rigidity. So the name of the car is a semi-rigid car, and we looked at shark skeletons because they don't really have a skeleton in the traditional sense. They have only cartilage. So that's a skeleton I'm interested in. And they also have these strange growths in there. The spine, not so interesting, but those things on the side where you have increased material thickness, which is related to increased opacity, and then decreased material thickness and capacity and opacity. Very interesting in the shark skeleton. And the implication there also is the multi-materiality of 3D printing, for which I find a car to be a really great scale. That's right around the corner. That kind of stuff. So here's a sketch of what that might be when you begin to determine. When you begin to put one material inside of another. So imagine this is a kind of silicone matrix within which you have a more rigid material only in areas where it's needed. And one of the nice things about working with all polymers instead of mineral materials, again, is you can begin to pull up almost like slabs of skin. You can begin to pull up or wrench or wrinkle the skin on the car, and you don't have hinges or anything like that. It's all one giant living hinge. So here's when you pull out some of the internal more rigid areas from the inside. And I love this idea of stuffing things inside of things. So frankly, for the effects of being able to have depth in the surface. But in this case, we're starting to think of, what are some kind of, ways of having biological glow, or maybe an algae bioreactor in the hood or whatever. So we're starting to stuff objects into this thing and then dip it all in silicone, more or less. So you've got some actuators in there where we're kind of saying, how would we trigger how would we trigger the living hinge on this thing? And again, this is not an overall solution for a car by any means. I'm not an expert at drivetrains, but this is sort of an architect looking at the things that an architect might be able to contribute on, which are, I guess, issues of surface, enclosure, skin, embedding, those kinds of issues. Aperture. One nice thing about 3D printing, of course, you can just 3D print if you got a flat tire, you could just 3D print the entire thing out of more rigid rims and then into rubber without having to have tires or anything like that. And whoops, maybe I'll show that. And one other thing too, this is just a concept, but interesting to think of how you might be able to roll up a car like a sleeping bag and pack it for transport from wherever it's manufactured, rather than having it in those strange containers down at port terminals. So. This is a piece of public art, which is a kind of a prototype, and it basically considers what I'm basically calling low profile technology or super thin technology. There's a lot of that coming on the market. Everyone is familiar with it. I'm not sure that we know yet as architects how to deal with it. You see a lot of these things being kind of glued on to conventional structures, so I'm trying to figure out how we could begin to embed that into composite construction. You have thin film solar on the right, you have electroluminescent film on the left, you have OLED, of course, from the new Audi cars, which is kind of amazing stuff. So this is the project that we came up with, which is a kind of loopy, tattooy, multi-material project, which goes from composite to electroluminescent to acrylic inlays. And we started this project, we gave it a form and we analyzed it in ANSYS, and we decided that the areas that are under highest stress were going to basically need to stay as composite structure. So those are going to be fiberglass. And then the other areas were a little bit more open for discussion what they were going to be. So we figured that the areas under least stress could begin to become acrylic areas that are basically snap-in kind of structures. So, oops. Now, the project was really important for me and for the office because we began to misbehave a little bit with the engineering model here, where first of all, we brought it into ZBrush, which is probably a no-no to take a structural map into a painting program. And we began to look at it aesthetically and try to leave the areas that we knew needed to be a certain way and in terms of engineering, but then completely interrogate it in terms of the aesthetics and change it where we thought we could, because we wanted more loopiness, more leopardiness, and those kinds of qualities. So these are just some of the studies that we did on this piece. So there's the final thing. can see some inlay of 3M thin film tape in the black areas. The white is just white on the outside. On the inside, it's electroluminescent on the acrylic. Another prototype that we did after that, when I was just starting to get sick of things that are ultra thin, it's what happens when you begin to delaminate the surfaces again and create real objects inside of objects. And so we took a two-surface piece, top surface, bottom surface, and then began to have huge involutions in the bottom surface so that we would actually have objects behind aquarium-type apertures. And we began to really push the envelope of the paint so that we would have the black polka-dotted or spotted pattern on the outside would be this solar inlay, and then on the inside we might have electroluminescent inlays which are more like tiger stripes. So we're going from cheetah to tiger here, and I like this piece just because it has volume to it. It's not super thin, but it's based on super thin tech. So those are some of the prototypes and thinking, and we, the work over the years since I started my office about now 6 years ago. We used to do a lot of work on the issue of surface to line, and which basically means teasing things out of surfaces, like taking a wire and teasing things out, particularly pleats out of surfaces, which was really productive and interesting. And I think, though, that the work more recently has been more about surface to volume, which is the same basic idea where you're trying to create transitions or transformations between things which are ultra flat and then things which are more volumetric. And I'm finding that that's more useful in terms of building design and organization. The other one, the former, is more maybe more useful in terms of articulation of surfaces. So surface to volume has been a big focus. A couple of images of what I mean by that. What happens when, like in the octopus head, what happens when you transition from a blobby or bulbous volume into something that's incredibly thin, like its skin there. Same with the car. You can fluctuate between 2D and 3D effects, which I think is really interesting. And of course, you're way beyond you're beyond the single surface project because you're in a hybrid land of 2D to 3D. I always like skin. The idea of skin over surface. Surface is very abstract to me, but skin I like very much because it's constantly changing in dimension and material, and I think it's a great model for thinking about architectural skins. And so I like to think about that and objects inside of objects. The second part of that, on the left, Bart Hess. If you know him, amazing artwork, STRP Mutant series. He's a Dutch artist, amazing work, where there is an object nested within an object and some affinity between the two, and some interstitial space in there, but not an actual fusion of the two. As a kind of opposite of that would be the Russian dolls, where you begin to put things inside of things maniacally, but they just are offsets or isomorphs of one another. So that's the first one is push the wire through the rubber sheet. This is put the figure in the sack model. That's what I've been calling it. Couple of examples from history that I think a lot about. The Farnsworth House. How do you begin to take something which is volumetric and unfurl it into, in particular, maybe an entry sequence or other kinds of space which are defined by the architect, but not but transitional spaces from when you're in the world to where you're actually inside. It becomes a very interesting processional kind of space. And at the same time, the Le Corbusier Museum on the right, which is separate objects and a kind of a roof. In this case, rather than a ground, you have a roof, but separate objects, and there's some delineation between objects here. What is a figure internal, and then what is a kind of loose outer boundary. And I think these are great models. So here's the Farnsworth House, and then the project I'll show very last today on the right, which we did recently. And I had fun making this little model here. Why am I showing this? This is the Taipei Performing Arts Center, which is a surface to volume project. At the same time, it's a surface to line project, so you can kind of date it with that. It's about 4 years old. and it was a big open competition, so everybody did it. And I guess one of the important things about it was that it would go from razor thin on the edge to volumetric, and in this case, it also has cavities in the inside, and the cavities are a kind of concourse space that connects several theaters together, and are really a kind of the cavities are very urban, and again, it's beginning to break down, I guess, the hard edge of the building and beginning to draw out the space between the building edge and the interior. So, and this is a very highly articulated drawing out of that, where you begin to see pleats here inferring some kind of stiffening of composite structure. You notice there are not conventional subdivisions on this on purpose. There is, however, if you look closely, there is starting to be some additional patterning there on the left, almost Aztec-like, which is also one of the sources of the tattoos that we've been working on recently, which is a substitute for conventional subdivision. Project in Puerto Rico. Don't know what is going on with this, but this is something that my friends Hernan and Marcelo, the three of us, are working on to make happen in Puerto Rico, and we've made a lot of trips down there, so this is a real project. And the proposal is from the Pontifical Catholic University of Puerto Rico to build dorms. They need 2,000 beds, so we're building some high-rises down there. And yeah, so of course, I actually find high-rise design to be incredibly difficult. So I appreciate people who took that on today. So I went with something spherical, of course. That makes no sense. But I really like this model, which I call the implied outer shell, where you have an internal figure or mass which has surfaces which pull off of that and begin to create a secondary enclosure or implied outer enclosure, which is not total. And I wanted to use this to make the dorm. So here's the project. That was one angle. How do you begin to create something within something else in a tower type? Almost impossible. The other thing I wanted to do was to separate the building from the ground, which is something that I've also been doing intuitively for a few years, and I'm getting more excited about because it begins to objectify the piece where it's no longer a landscape project or a single surface project, but it's actually an object which is nestling into the ground. Something I'm working on right now also is to begin to give the ground itself more character. But I like that very much, that it's kind of a no-no, like you don't do a spherical organization for a vertical organization. You don't let's say, burrow out underneath a tower, which should normally be a cantilevering beam out of the ground. But I think it has certain effects that work really well. It also creates an interesting internal organization in one place where what you think is just a single surface on the left, this razor-sharp edge, actually opens up, delaminates, and there's space inside, so that becomes a shared public space that you can actually leap over on those bridges and inhabit that space and have a view out. So, and this is the back. This is rough and tough. This is a real project. If nothing else, if not for economy, this is for strategy, this image, if you know what I mean. And this too. This is in Puerto Rico. This is where you build with concrete. Why hurricanes? Why longer-term history with building with concrete and a kind of feeling of comfort of building with concrete. So the red is the only steel area in the whole project, and those are just pipes. They're pretty straightforward. So here's the piece. Punch windows, very difficult, hard call. I don't know how to solve it any better. There were probably 100 versions of how to do windows in a dorm, which you have to deal with. I found this to be the one that interrupted and hurt the massing the least. Surprisingly, there were a lot of other ones. Okay, older project, which you know probably. This is PS1, which is actually quite an old project now. It's 10 years old. But I brought it back because it is objects within objects. And in this case, these are structural cells, which are kind of arrangement or swarm of cells that are objects themselves, but that have a loose outer skin around them to create shade. So, but it is an early I'm realizing the more I think about it, is a kind of early version of the squishing and also of the object within an object. So I wanted to show that. So squished, as if vacuum formed, although made out of minerals, squished, and also the object, the structural members, not so interested in them structurally. Some of them are 50 feet long and they're doing a lot of work, but way more interested in them as objects nested within a loose outer skin. So here's the piece during the day, a complete opposite of the nested cell, which is quite nice too, so you read it as an object without its internal objects. So, another old one, brought it back. This is a competition that I did in '07 for the Prague National Library, and it's something that I'm finding the more I think about it and begin to categorize some of my projects, it's actually coming back. This is a National Archive and a library, and it was a kind of a, everyone knew about this competition at the time. It was won by Jan Kaplicki with a very similar scheme to this, actually, a kind of a mountain. One interesting thing about it is that the height limit was only 15 meters, which was this high. So it was one of those where you had to break the rules in order to make the final cut. And the reason why I'm showing it is because it's the beginning of at the time I was calling these buckyballs. It was very informal, but the buckyball was basically an implied outer shell, where you have something in the inside and you have an outer shell which has huge apertures in it. And so I realized recently that that's actually part of this lineage of the Implied Outer Shell project. So here you have the National Archive, accessible from almost nowhere, visible from everywhere, from the library at the bottom level, which is public, and then the reading rooms at the top, which are private, and then the thing is suspended above the ground. Again, you asked maybe why. They had flooding in Prague the years before that. They lost a huge part of their collection. It was actually required to have the books off the ground, so I thought I would make that the project. And so there's a second skin around the entire thing, which creates a nice environmental and depth buffer around the object. So there's the organization of it. The view down onto the public space and out to the castle. And the plans. So another older one. This is from 2010. Figures in a sack, objects in a sack. This is for the Kaohsiung pop music project, which another big uninvited international competition. Really fun site. The entire waterfront of this old kind of port area of Kaohsiung. They wanted to turn it into a kind of multimedia music environment with indoor and outdoor amphitheater and those kinds of things. So I decided to make a multi-layer, multi-material sack, stuff it with the theaters, and then begin to cut away at it with what we called glance cutting. So basically complex surfaces that were not normal to the surface, but at angles, so that we begin to reveal the different layers and reveal the objects inside. So it would kind of hover between the mysterious quality of something in a sack and also revealing those objects inside. So there's this thing, some of the cutting and studies that we did, surface to volume, glance cutting. And some patterning on there for thin film solar as well. You notice the patterning doesn't continue, it stops where you have the thin film. And here's the director's cut at the end. This is not the one we sent in, but this is the one everybody liked the most. Okay, so okay, here's another project. This was actually for the Venice Biennale, so it wasn't really a competition. That's why it's not worked out. But as a concept, we wanted to do it. This time, more mysteriousness, stranger figures, stronger edge figures inside of the sack, distinct fall-off conditions where you're beginning to understand what's inside, but then in other areas falling off into membrane. That was very important. And so we did some of these fun videos here. Don't mistake this for a draping algorithm or an engineering solution, although it may have some of those qualities. The minute you stretch a membrane, of course, you've got a stronger and better performing membrane, but we love this little guy pushing through here. So, okay, let's keep going. So here's some of these figures in the sack. And then I think that the more important thing on this project was that we wanted to get away from the uniform blobbiness of the thing on the top, although it's quite differentiated. We wanted to get away from that. So we invented the idea of the supercomponent model. In this case, that meant putting a sack on there around the figures and then almost inflating a balloon inside, which we call the liner, which is the green thing. So you inflate it, you let it squish around and tuck in around the figures, and then you remove the outer sack as if it's a tool or a mold that you're using to get the liner. What's the payoff of doing that? The payoff is that you can begin to get these joints. You get continuity between multiple massive components, which is then emphasized through the introduction of the tattoos, but they're separate objects. So you can imagine there's actually a space in between the supercomponents and then the liner. So that was a nice discovery because we got away from just the uniform kind of topological thing there. So here's the side view. You can see the outer figures in some points actually pushing into and through, so you can see them through the front. So very undeveloped, but that's what we showed at the Biennale. This project was for the Busan Opera House. I'm sure people in here did that one. That was a big one. It was more recent. And in typical fashion, a kind of site that's not a site, a context that's not real. It's this is an artificial island. Probably was a landfill. So and then we had one corner to work on, and we didn't know what the rest of the development was going to be. So we just thought we would kind of work on the spherical project there, and go vertical, but go spherical. And again, we used the model of the implied outer shell. In this case, it was very useful because there's extreme weather here. The monsoons and the sun are very tough. It's very humid. So we really almost needed to create an in-between zone that they could use for some of the outdoor activities that they wanted to host, which would never have worked if we didn't do that. So you see these kind of pieces of skin peeling off. So it creates an indoor-outdoor microclimate there. The tattoos are maybe more aggressive in this project. We're just starting to come to terms with what these things are. I don't even know if we were calling them tattoos at the time. Where they're starting to have figuration, which is independent from the object. In other words, the drawing needs to be worked out in parallel to the object, to the massing. In other words, there isn't a complete one-to-one correspondence between formal features and the drawing features. So here it is as we applied it. It begins to both emphasize some of the formal features and break some of the formal features, which was really important, and also organize all of the apertures. If you notice, there aren't any freewheeling apertures. They're all organized within this tattoo. So here it is at night, and the object during the day, the theaters. Structurally speaking, it was interesting, although not worked out. When we removed the apertures and then did an ANSYS analysis, we realized that it creates a huge heterogeneity of force flows in the surface, so that's potentially where one might begin to stiffen the structure in some fashion. So there it is. Okay, so tattoos. I need to say something about those because you can't just say the word tattoo in an architectural lecture and not expand on that. So tattoos and the status of subdivisions. What is a tattoo? Why am I talking about this? I find it to be incredibly precise for what I've been working on recently, and so I use it a bit with chagrin because it does seem to be a cheap kind of word, but it's actually not the way I'm thinking about it. I find ornament to be so overused that it's almost meaningless. I don't know what it is anymore, so I'm trying not to use that word anymore. It tends to sound like something that's hanging off of architecture, that's not fully embedded in or part of the architecture, so I'm kind of canceling that one out. Supergraphics, also not so interested in that, where you're just mapping 2D things onto 3D objects. I'm way more interested in this embedment, and which is what a tattoo is. It's fully embedded in the skin. I can't get rid of it. And it's also, in a lot of cases, tattoos tend to be incredibly strong figurally and have hard edges because of the way that they're made. And I like that very much, that there's a kind of a hard edge, almost an object-like figure of the tattoo So it's not just a field, but it's figural. So free-form figuration over the expression of surface subdivisions towards composites. So this is, again, the tattoos to me are completely related to my way into how do we begin to create a composite tectonics as architects, not as engineers solving problems, but what do we want to invest in this project? Things which may be performative, but which may also have other languages. The discussion of tattoos, really interesting. Came about, of course, through colonialism when everyone in the Western Europe was trying to figure out what was going on with those tattoos when they saw them in the mid-19th and earlier. And Charles Darwin also looking at that. And, of course, the applied arts, like people like Semper and Riegel, trying to figure out the source at that point of tattoos. People were trying to figure out the evolutionary history of tattoos in the case of Darwin and maybe Semper. And the relation to underlying structures or musculature, whereas this guy Riegel, Austrian, very much invested in this idea of Kunstwollen, or the will to create. He insisted that the most important thing about the tattoo is the spiral, and that shows that it has nothing to do with underlying facial structure. Whereas Semper was saying, oh no, everything that's on there is somehow representing the underlying structure, which was his theory, of course, on architecture and Bekleidung. So this is a building I lived a few blocks away from in Vienna, from Otto Wagner, the Linke Wienseile, a tattoo building, which I think about not necessarily as an inspiration for the tattoos, because I find it very flat, but it is quite interesting the way that there's a lot of difference. If you actually look at it, it's not just a standard print like you'd find in carpet or textile, but it's actually different across the facade. You got to walk by it a lot of times before you realize that. I find that the window punch holes are very disturbing, and they don't seem to be affected at all by the tattoo layout. And also the size of the tiling on there relates and indexes the kind of ceramic industry or concrete tile industry. I'm not really sure what the material is. So interesting as a kind of counterexample to what I'm talking about. Better example, possibly, the Mandarin Fish. Look at the tail of this guy. You have a complete alignment of color and articulation on the tail, which aligns with the cartilage of the tail. But then you have other things going on. You have a blue stripe going along the edge of the fins, which is beginning to enhance the outline and the strong silhouette of the fish, probably to make it look bigger. And then you have these free-form areas, which I just love, like on the body of the fish, where it's not relating in any visual or clear way to the underlying musculature or bone structure of the fish. And then it goes haywire when it turns into polka dots and runs across the eye of the fish, which it shouldn't do, and all of this kind of thing. So what's interesting to me is not that it's completely free-form or wild, or definitely just texture mapped on there. It has these elusive and complex relationships to the fish, but in some areas it seems to deviate entirely from what it's running along, which I find very interesting. Other examples, even more extreme, the Flowerhorn Fish at the top. This guy is a completely artificial fish, bred for captivity. These things are really valued in Asia, and what I love about it is it looks like literally Chinese characters are imprinted on the fish, which they're not. This is like been, over generations, been developed. Also the bump on the head, which seems like another kind of tattoo to me. It seems like scarification or other things. And very interesting that it has a kind of underlying color pattern emphasizing the fish, but then it has that additional figuration. Same with the cat down below, beginning to see patchworks of materials over a kind of finite element or subdivision logic. Very nice tattoos when they go beyond just being on the surface, when they start to have to do with embedding. And of course, this can get kind of horrifying. This one I find quite beautiful. So let me show a few more projects here on tattoos, and then a few more evolved projects. So this is a project from MoCA in Los Angeles. There's a show called The New Sculpturalism, which is tracking the work of LA architects for the last 30 years. And I am working on this right now. In this case, there were some pretty tight restrictions. 15 by 15 foot bounding box on the floor, 20 foot high, had to be inhabitable, had to be an actual space. Also had to be open to the sprinklers so that it would be transparent to the fire code. But we decided to start with a crystal-like form and push some crystals in from the outside in order to create mass on the interior. So here's the base form of the piece, where you're getting something that appears to be incredibly massive or heavy, but it's actually razor-thin surface. Here's the piece, very simple and crystalline on the outside, and on the inside kind of gooey and soft. And you can see there the poché is extremely razor thin on the edges and all the visible edges, so you read it as 2D thin surface, and then it becomes sort of lumpier and fatter in the internal areas. So there are the tattoos relating to the moments of the most stretching pressure there in some fashion, but also going completely freestyle and freeform in other areas. So trying to highlight it, but also deviate from it. This is one of the pattern studies for that, another one. One of the interesting things about this piece is that it is actually composite, although it's one of those budgets where you kind of build it out of whatever you can get for the price. It ended up being composite because it makes the most sense. And one part that I like about it very much is that what seemed to be excess or unrelated to underlying features or structure ended up being a way of friction fitting pieces together. So the tattoos themselves actually are reverse engineered back into joints where pieces begin to fit together with a limited amount of fasteners. So it's kind of stable almost just when you assemble it, like puzzle pieces. And of course it had to be broken up to just be moved in a truck. This is a prefabricated piece. Oops, let me show this. More sack. This is a project for a graduation pavilion for SciArc, which was an internal competition that we did last summer. Again, this idea of pushing on something to get fall off conditions. And here's the piece. The program was to build 1,200 seats that are in shade, and for basically lectures and symposia and all kinds of things. Patrick, I think you lectured there when it was a big empty pyramid with no cladding on it. And so the school wants to have something a little more permanent. So this is the project. I wanted to make a full enclosure on it that could be used for other functions. And this is an incredibly tight budget. Also, kind of seat of the pants. Here's some of the tattooing section of it. So it's got, again, a lot of sectional poché qualities to it. But I guess the most important thing for a project like this, which was a realization project for almost no money, was the way of building it. So we called up some shrink wrapping people, because I thought that would be consequent, materially speaking, to try to use shrink wrap on a shrink wrap project. And not knowing what was involved, but it turned out that, and I love this image, by the way. This is incredibly mysterious. It turns out there's some kind of gear case, which has been sealed from termites and mold. And so I saw this online. I was searching around, and I called up this guy in Arizona who shrink wraps helicopters and all kinds of military equipment. And we talked about it, and it turns out it's viable. And one of the really important things about it was that we could not figure out how to shrink wrap the outside of it, and it has a steel frame. The outside of it, and then shrink wrap the inside of it, because it's shrinking, so it's pulling off. So how do you do the inside of it and the outside of it? And we scratched our heads for about a month, and then we figured it out. We have to do super components. So we hacked the thing up into big pieces that could be shrunk wrapped as objects. So huge chunks of construction that could be built as steel frames, and by the way, importantly, without any secondary construction, only temporary nylon strapping that you use just to hold the material before you shrink it. You remove it, and then you assemble these chunks in like a single day with a crane. So that made it feasible for the budget. So there it is. This is a house project in Lugano with an amazing view, and it's really, frankly, it's all about the view, I have to say. This is an amazing property. An artist owner, a musician owner with a big family, and has had this property for a couple of years. We've been in contact, and it's a great piece of property. And so he's living right now in a loft that he built himself, and So we were basically asked to just sort of mimic the area that he had in the house now, in the new house, and that was the program brief. Oh yeah, and the view, of course. So we took on those things, and I wanted to try to separate what looked like kind of a slab building, separate that into clear objects with separation from one another. So in this case, we started with a very, very strong figure, which would become the main public living space. Connected it back into the hillside with secondary support spaces like guest bedrooms and a studio, and then putting the whole thing on top of a pedestal, a kind of a pedestal which keeps it up in the air and off the ground. So the aperture became the main feature of this chunky form. And at the time, actually, I just looked at some Frank Lloyd Wright with some of my students. I wanted to go look at the textile block houses for the angle on tattoos, which I find interesting, and noticed how Frank Lloyd Wright was actually dissolving away an aperture by adding a bunch of micro apertures around it, and I thought that was really interesting. So the wrestling mask is doing the same thing in a different way. It's starting to dissolve the edge of the aperture through a secondary figure around the aperture. So that became the idea for making a giant window to look at the view from this house. So we began again with a drawing, which in this case was on an unfold. The black lines are the edges of became two massive apertures, and then the red lines are the seam lines between the composite construction. So you'll notice that wherever there's a fold line, that's an edge, and the red lines tend to be 90 degrees to that. Of course, in composite construction, you don't want to run a seam along a corner if you can help it. You want to run counter to that to maintain the strength of the seam. So you get this kind of wild drawing, which is both a definition of the aperture and also a kind of breakdown of the components. So here's the piece, beginning to almost atomize the window, both define a window, but atomize the window into sub-windows through the tattoo, which is, you'll notice, not everywhere. It's intense in two main areas where the windows are, and then it disappears, and then in addition to that, you have some sort of dashed lines, which are an index of this drawing, which I like very much, which can be built just like that. So there it is on the inside. On the inside, you have channels that are embedded in about an inch, so it becomes an embedded drawing on the interior. Plan very straightforward on the pedestal level, and then the living area is basically an open kitchen, dining room, living area. The composite construction here, puzzle pieced together, originally intended to be just composite with foam in between. So imagine fiberglass on the inside and outside for stiffness, and then foam on the inside for insulation. However, it turned out that because they're musicians, that it needs to be incredibly quiet in there, and you don't get a lot of mass for building acoustics. So one way to get around that was to get the mass through GFRC panels on the inside and outside, but that seems not cost effective, so we actually ended up having to go with a steel frame with a steel deck, concrete on that, and composite for the skin. So that's the tough reality of where we are right now with composites, but really interesting learning experience. I hadn't even thought of that angle. So here's the final piece. So I want to show, Theo, how much time do I have? I got good, okay. I'll go really quickly. I just wanted to show some larger projects and maybe a couple of the issues that are involved in those really quick. I've done a lot of work in China over the last couple of years, and it's good to show it because the scale is so different than some of these other projects, and it does require a different strategy in a lot of cases. So I like to say that, and it helps me to think about some of the work that I do is runway, and some of it is pret-a-porter, ready to wear. So China, the strangest things happen there when you go to China. I won't go into it, but maybe later. This wasn't one of them, by the way. But this is my local partner. Of course, we have to have a local partner. And this is the funny thing for me about this picture isn't that I'm taller than him. It's that what I remember actually happening that day, which was that I was informed that I was hired to design I think the hotel is first. Oh, this is out of order, but anyway, this picture that I was hired to design a hotel, and I was given 24 hours. I was in Beijing, and I was given 24 hours to design it, and then, and I didn't have anybody with me either, so I was by myself. That was interesting, and then present it in public to I don't know, thousands of people on a stage, and it was horrifying, and then there's a design. And it's there, and you have to deal with it. So I'll show that to you in a second. This is a different project, though. This is a competition that I won in Shenyang, China, for a sports complex. It's this entire block here, right in the middle of Shenyang, next to this park. And for some reason, I got into a lot of sports projects there, and actually they're pretty easy. I have to say, like, go do sports. It's good. A lot of volume, not that hard to figure out. So this is a project that we did for the Taekwondo arena for the Chinese National Games. It's not going to be built. We thought for a long time that it would be, but we did get first place in the competition. And it's quite large. You can't tell by looking at just the object, which actually is large, but the entire block is all our work. So it's basically built like a parking garage, many levels. All of the sports field are all planned by the office. And then these are just the kind of key arenas to be used during the national games, and then cleaned out to create a giant civic center at the end. So we planned it with wood floors and all of that, so you could clear out the national games stuff. They got burned in the Olympics in China. They never wanted to do that again. So everything's multifunctional now. So it's 1.2 million square feet. It's quite large. A lot of that is in the parking garage, which of course makes that thing possible there. The strategy that I use a lot is what I call the 2080. Or the 1090, or even the 595, depending. In this case, 20% means 20% architecture, 80% parking garage. Only way to do these projects, the budgets are low and getting lower. And so here you see the layout, very, very straightforward, supporting stuff. Now, check out these delaminated, double delam surfaces. Check out that composite construction. I just want to show you, like, the reality of what you plan for and then what happens, even before bidding. Something like this could happen, basically space frame trusses, that could happen definitely during bidding as an alternate. It happens all the time that you lose control of what the structure is. It could switch from concrete to steel. In this case, we just literally couldn't find somebody who was willing to do the engineering of the composites. It wasn't even that we couldn't find someone to build it. It's that nobody wanted to engineer it. So we had to do a vector structure. It was off the table right off the top. So we had to develop a vector structure. At the end of the day, if you can, as a first step into this language that I'm interested in, if you can simulate it on your first try and then you can do it for real the next one, I would have been happy enough, I have to say. Patchiness on the big giant windows, one of which looks out into the park. Some are semi-opaque, semi-transparent in order to have some more hierarchy there. This is one of the many, many, many models we made in China, milled out of a solid block of plexiglass and interior. I'll show you this video. You'll like this. So for those of you who do competitions in China, you may know this whole thing where you're not allowed to present, but you have to make a movie in Chinese, and it runs for 10 minutes, and you're not allowed to say anything. So I'll show you. Oops. I'll show you just a little clip of that movie because I think it's I don't know. Gotta have it. This was made on Christmas Eve when the competition organizers decided that the 24th was a bad day and that we should wait until the 30th and have more to so I spent Christmas in Shenyang. Anyway, it's too bad that didn't happen. That was exciting, that project. It was right in the middle of the city. So let me show quickly two more projects. I'll go even faster, I promise. This is a hotel right next to Beijing Airport from Foster in the 5th ring of Beijing, where they're starting to develop now. They've really filled up the rest of the rings. A hotel is difficult when the optimal shape is like a Las Vegas hotel on the left, but you're, of course, because of the airplane restrictions, 45 meters, you have to actually chop that up and put the pieces down on the ground and do a horizontal hotel. So that's what we did. We took 3 rings. This is, by the way, the project that was done in 24 hours. So 3 rings that are connected together, which have some of the rooms have views to the interior and some to the exterior. Why are some looking to the interior? Because the client wanted a 10,000 square meter rainforest in the inside of the building. So he wanted some jungle rooms and then some city rooms. And also very important, of course, is that airplanes are flying over this thing all the time. So you need to be able to see in through the top. This was part of the brief, which was a paragraph long. You have to look in through the top and see the rainforest as you fly over it. So here's the kind of what I would call the machine inside of the loose outer skin, the sac, which is, and it is loose. The outer skin is not the weather enclosure. It's a loose skin. And so the rooms are all, luckily we had a script to run these a bunch of times, but we had 1,500 rooms, which made this thing the biggest hotel in Beijing. I had to run them and rerun them. You have a lot of parameters that's very difficult because you're dealing with an 8 by 8 meter concrete column grid, and then the kind of complex geometry overlaid on that. So that was a kind of a fun little puzzle to figure out. The project another part of the brief was that it had to be white. We didn't know why, really. It seemed to be just the preference of the client, so it was white. And we decided to sneak some color in by saying that, well, the inside of the shell can be colorful. And we said, and they said, well, why? And they said, well, by the way, this is China. You have to have a metaphor, or we don't understand it. They literally told me that, and I was like, okay, I can do that. I get it. Bird's nest, water cube. So we decided it's the white dragon, and that the inside is the phoenix. The white dragon being a sign of power, and there are 5 dragons and all of that stuff. So white dragon, and then phoenix on the inside, which is the yin-yang opposite, more feminine, whatever on the inside, and seemed to make sense for a while. Actually, what happened was that we continued with that metaphor for a while until we got up the food chain, and then we were with the Interior Minister of China, who then told me that he turned white, literally turned white when I said it was the white dragon, and maybe it was a bad translation. I don't know what it was, but he looked at me in horror, and he said, white is the color of death in China. And he said, it can't be the white dragon. And I was like, what? Come on! Because everyone else had advised me the white dragon was good. So here's one of the entry areas. There's you can kind of see some of the yellowish color coming through there. A kind of garden-like thing between the outer skin and the inner skin. Starting to see a dual pattern, which becomes important in a minute. So here's that thing. I mean, it's 300 meters long. It's pretty huge. Kind of squished from both sides. And there's the scale of it. You can begin to see that the dual patterning there of, obviously you need to have a ton of openings. So it's like, how do you shred a mass to the most you possibly can without destroying the mass? It's a difficult problem, and then at the same time we wanted to add a secondary patterning there, which became really important for the project. At first it was aesthetic, and then we figured out that we needed to deal with, what do you deal with in a hotel? Water. Hot water needs are huge in a hotel, so we made a thermal heating system with pipes embedded, sticking out a little bit above the panel, so you begin to read it as tattoos on the thing on the roof, and then on the underbelly. There are cooling pipes because this thing is seriously picking up a lot of heat in the summer. So it's all it's cold water and cool air descending on your head. So here's some of the plans, some structure. We ultimately decided to work with a cable mesh option for lightness and fiber composite panels. So yeah, I just have to show this. So again, this is that event where it was, and you gotta love. Last project, sorry to keep you guys, I know it's long, but this is recent though, and I want to show it. So this is important to me because, Tom Main from Morphosis invited me and 4 other people to do a joint design team, a pitch for a project in China, which is the Hong Kong University China, Chuck, in Shenzhen. And there's a big movement right now of... There's a... I think I said something wrong. There's a big movement now of these, of like Hong Kong and other universities moving into the mainland. And so we knew this was a go. This is a big, it's a whole university from the ground up. This is only phase one, in fact, of this competition. So we pitched. Tom led the team, Max Scoggin, Neil Denari, John Enright, Brendan McFarlane, and my office. And this is the kind of, after the master planning was done, then we all took some buildings and had only a few weeks to do it. I, of course, did sports on the far left, lower left. This is my project. Neil is up there, the two sort of chunky boxes. Tom's in the middle with the library. Mac did the labs and some dorms, and then John Enright did the admin building and the dorms in the back. So this is kind of us working at Tom's office. It was really fun because we actually installed ourselves there. We all brought people over, and we worked on his mezzanine together and had a lot of feedback. It was quite fun. And I enjoyed that. And so, yeah, so that's this project. And again, pulling skins off of this is the arena that I was working on, although there were other programs. There's all kinds of sports annexes and gyms, and basically the entire sports program for the university I decided to kind of put together in a big mega structure. And this is starting off with what is the arena, how can we begin to peel skin off of this and create some interstitial space or some kind of some procession into this thing. Starting to also realize that there's a phasing requirement in the brief where the thing has to be done in two chunks, so we can't have it be a big topological form, which I was done with anyway, so it was really nice to have a huge joint down the middle, make it appear as one whole, but actually be two different mega components. And then deal with this idea of an object which is starting to unravel in a way, or unfurl, and create a shell which is implied, a secondary skin, but doesn't go all the way around, because of course economically that doesn't work, but also I think this is interesting in terms of drawing people up inside of it, and then into the arena. So there's the second phase. Would have been tough if they didn't build the second phase, but was okay. We worked on it in such a way that we could have lived with it even without the second phase. We're right along a promenade, so how do you go through there? And the tattoo on this project, we decided to go extremely bold and tough. We had a meeting with Arup, and they informed us that there are new extremely tight energy restrictions, tighter than in Germany now and southern China, and that we had to have a ton of solar on the roofs, and I was the only one up for it out of most of the architects, so I took it all, and we made this really fat, tough tattoo for the roof to take care of those requirements. So there you have the tattoo. Again, trying to run along some of the edges and enhance them. In other places, running completely across form, like a no-no in a way. And then meta seams running around the objects, kind of tying it all together. But again, there aren't actual mineral material divisions, but sort of mega divisions. So here's the piece, the layout of the sports arenas. And then this is a secondary enclosure within the outdoor space. So you come up on the plinth, you begin to enter the building, then you go up the stair, and then you're on a sub-level, and you enter again this glass piece, which is shoved inside of what is outdoor space. So you're kind of in these gradients of gray spaces, and then you're actually in the space. So there it is at night. And this is the other side facing the entry as you drive in from Hong Kong, and you see that joint running all the way from the roof down into the ground, creating two separate buildings shoved together. Very important too, and the last thing that I'll say is this building is on the ground, but it's off the ground. The channel running along the edge is incredibly important, that it's resting in the ground, it's not merging with the ground, this is not a landscape project, it is definitively an object that's lifted, or at least visually faked to look lifted off of the ground, so that it has a tension with the kind of plinth that it's on, and that it's that it's more object than it is landscape. Thank you very much. And thanks for your patience. Sorry to go over. I'm sure I went over. If you guys have like one question maybe, or... Yeah. Patrick. How did I know?
1, 2, 3. So, well, great work. Congratulations, fantastic.
Thank you.
And seen quite a few of the things I knew relative to when you were here last time, which was I think 2 years ago.
2 years ago, yeah.
Anyway, I do want to ask the question whether the what you call tattoo is doing work with respect to the social functionality of the projects. Whether you see this, to what extent do you feel they can be instrumentalized, or do you want them to be instrumentalized? Are you considering this at all, or are you staying in a purely formal discourse?
Well, I don't know if anything's purely formal. I mean, isn't it always judged by the social being? I mean, I'm not sure if I can entirely answer this question in your terms. I'll give it a shot. Social function. I find
I'm saying
it
social because partly it coincides with technical function.
certainly
Partly only.
only partly.
Yeah.
That's right. This is not.
How
an
about social
efficiency.
functionality?
Yeah, it's the intention is to deal with a longer term issue in architecture, which is that of articulation, which I take very seriously, and I find it particularly puts the onus on architects using composites to rethink what that can be. And so I'm going for something that's maybe large scale, at least in the more recent projects. I mean, it's evolving. I don't know yet where it's going to go, but something that's large scale and has is almost an object. Is almost an object. It's not a pattern or field that's relating to what it's on, but it's almost an object in itself. And what is the social function? I don't know if I can answer that.
Well, I want to maybe give some clues and hints, perhaps, where this might go, what I would associate this with. On the one hand, you were before kind of when you were rejecting super graphics. Was that the kind of mid-90s or late 90s hyper surface where you mapped over? Even at that point, you would have started a discourse of what this actually could do in terms of articulation. For instance, dividing a volume, subdividing a volume, or reassociating volumes through a second reading. So it would, in these terms, at least work with respect to reading the decomposition of the and the reassociation of what the volume was doing. And I think at that time was also the only thing, the most interesting aspect was of Andrew Benjamin's teaching here was when he was making he's talking about how the surface is made to work in the work of Adolf Loos. In terms of the internal surfacing and cladding, the distinctions between wood panelization up to a certain level and white above, and how this would kind of be a counter territorialization relative to what the volumes were doing, for instance.
Right. No, yeah. I think that's definitely part of it. I mean, when I think about tattoo culture, there's a lot of moving from 2D to 3D, which is something that I was trying to communicate with the massing idea, that there's a kind of unresolved quality between what is surface and what is volume, and I think that's why I like the tattoo so much. There are tattoo artists who will work directly on the body freeform, but a lot of artists draw it flat and then map it back onto the body. And I find it very interesting to have that simultaneous reading of something that's two-dimensional and three-dimensional.
Can I ask a follow-up question?
Yeah.
When you seem to be there's a kind of semi-rule-basedness. If somebody just told me that you're rejecting using scripts for color application and pattern application, and right now,
that's actually true, though.
And exactly, and I want to, and when you talked about what you like about the fish and how you then apply your tattooing, you like the fact that it's only partially rule-based and following logic, and then kind of plays itself free and utterly free. Yeah. And I can't quite follow. Can you rationalize this?
No.
Okay.
No. In fact, it's funny that you said it.
You just like
because
it.
Patrick, I remember I showed that video that I showed tonight. You've seen it before, where I'm painting on the structural map, and I remember how horrified you were. We were in Innsbruck. You came up to me afterwards, and you were horrified. You were, how could you do that? But then, if you remember, and I do, if you remember, I said, yeah, but it didn't look right. It wasn't a good design, so I had to fix it. And he said, oh yeah, right.
No. But I think after that comes I do trust those. Okay. Okay.
But you have my number, Patrick. I mean, what you just said is exactly right. That's what I'm trying to do. And the rejecting of scripting, it's not like that I reject it. Everyone uses script. I use scripting all the time, but I'm looking for something that's in between, and I've called it in the past messy computation, but I'm looking for something that's in between what is in control and what's sort of out of control and analog. And this is sort of where it is now.
My last challenge on this, that means your intuitions in some way or another might be still superior in terms of nuance and sensitivity, but I would just challenge you and say, try to rationalize it. Try to get the bottom of this. Then you can script it afterwards. Maybe it's more complex.
Patrick, I'll work on that. I'll work on that. I guess that's enough. Thank you very much, everybody. Really nice to see the work.